In the previous episode, Josh and Arobindo reflected on whether or not all numbers could be plugged into their equation for the height of the beanstalk. In this episode, they reflect on the types of numbers y can be.
Can you write the equation again? Y equals 3 to the x.
Okay, so it's y equals 3 to the x, right?
You can just turn
So in this equation, what values can y take on?
Y.
it can be the height. It's just the height.
Yeah.
The height?
Yeah, but it can't be like negative because the seed, when it's in the seed, the plant height is 0, but it's not negative. So this has to be, well, I guess y is greater than or equal to 0.
When do you think it was 0?
It was 0 when it was just a seed, I guess.
And how long ago from when Jack got it do you think it was a seed?
Well, like using the equation we get never, because so you don't know.
Yeah, so we discovered 1 day before its height was 1/3. What about 2 days before?
It just gets like, so it would be 1/3 on day -1, I guess. And then on day -2, you get 1/9. So basically, when you're going backwards, you're dividing by 3, right? So it's the opposite of multiplying by 3. So this is multiplying by 3, and this is dividing by 3. So if we keep on going, it'll go 1/27, 180 over 81, and then we keep on going and going and going and going, but we never get to 0. Because we just get a bigger and bigger denominator, but it's not 0.
Yeah, so the context kind of doesn't kind of breaks, right?
Yeah.
So if our tripling pattern continued forever in the forward direction and forever in the backwards direction,
It would never be 0.
It would never be 0.
And it also never dies, if you think about it. Because the plant just keeps on growing and growing and growing, and it just grows to like infinity.
So can you change your thing here?
You could like.
Okay,
Your-
y is equal to, okay.
Your inequality?
Oh yeah, it's like y is equal to 3 to the x, comma, if y is, I guess, greater than or equal to 0, and, well, and nothing else, because like,
But I thought you said it couldn't be 0. Do you think it can be 0 or not?
well, it
One day
couldn't be 0.
One day it had to be, but according to the equation, it was never 0.
Yeah, it could be 0, but what? Okay, we can just put y is greater than
In real life, it had to be 0, but
and we have no other conditions because, like, we can put anything for x.
Okay, so you can put anything for x. According to the equation, y is always going to be greater than 0, even though that doesn't really make sense in the context. What about 1? Can y ever be 1?
It was 1 on day 0.
Yeah.
On day 0. What?
That was the starting height.
Okay.
When Jack got it.
Another student said that the plant heights are powers of 3. In other words, they're 3, 9, 27, etc. Do you agree or disagree with that statement?
So by powers of 3, if they're only like integer powers of 3, so like 3 to the some integer.
An integer is any whole number. It can be positive or negative.
So like 0, I mean like 1, 2, 3, 4, and all those. Then no, because like, what about the square root of 3 we had? That's not, you're not going to do 3 to the integer and get square root of 3, because that's square root of 3 is equal to 3 to the half.
So when do you get heights between 3 and 9, say, for example?
In between a day.
In between a day, okay.
In this lesson, Josh and Arobindo found the height of the beanstalk over several times between day 0 and day 1. They did this both by using their equation and by reasoning about how the beanstalk was growing over various fractional parts of a day. For example, they found that the height on day 3/4 was 3 to the 3/4 centimeters using their equation, but also the fourth root of 3 cubed, because the beanstalk increases by a factor of the fourth root of 3 over each 1/4 of a day. They also reflected on what numbers could be plugged into their equation, and what numbers they could get out of their equation. They decided that they could plug in any number for x, since fractions just represent times between the days, and negative numbers just represent times before Jack got the plant. They also decided that y could be any number larger than 0. This is because, according to their equation, as you look forward in time, the beanstalk gets bigger and bigger. Then, as you look back in time, the beanstalk gets smaller and smaller, but never reaches a height of 0. This is because as you progressively divide by 3, the height gets smaller and smaller, but never reaches 0. In the next lesson, Josh and Arobindo will use what they have learned through the exploration of the height of their beanstalk at times between day 0 and day 1 to find ways to determine the height of their beanstalk at any time.